Imagine a young boy just 5 years old, lying sick in bed, his small frame bundled beneath heavy blankets. The world outside his window is quiet, but inside his mind is restless, searching for something to occupy the long, lonely hours. One day his father enters the room and gently places a simple pocket compass in his hand, a small, mysterious object that would change his life forever. The boy turns the compass over and over, watching in awe as the needle swings and settles, always pointing north. No matter how he twists or tilts it, the needle remains steadfast, as if guided by an invisible hand. There are no strings, no gears, no obvious explanation, just a silent, unseen force at work. The mystery of the compass fills him with wonder and 1,000 questions. That curious boy was Albert Einstein. In that quiet bedroom, a spark was lit, a spark that would ignite a lifelong passion for unraveling the secrets of the universe. The compass revealed to him that the universe is filled with hidden forces, invisible yet powerful, waiting to be discovered by those who dare to ask why. Later, a family friend noticed his hunger for knowledge and gifted him a book on geometry, an ancient text filled with diagrams and proofs. To young Albert, this book was more than just pages and ink. It was a revelation, a glimpse into a world where pure thought and logic could reveal absolute truths about reality itself. These two experiences, the mysterious compass and the logical geometry book, became the twin pillars of his scientific life, shaping the way he saw the world. One showed him that the universe is full of mysteries, hidden forces that defy easy explanation. The other taught him that the mind, through reason and imagination, could unlock those mysteries. Einstein's journey didn't begin in a grand laboratory or a bustling classroom, but in the quiet corners of his own imagination, fueled by curiosity and wonder. He learned early that the greatest tool for discovery wasn't a machine or a book, but his own mind, open, questioning, and endlessly creative. This spark of curiosity kindled in childhood would one day illuminate the cosmos for us all, forever changing the way we see the universe and our place within it. As Einstein grew, his curiosity clashed with the rigid German school system. He hated rote memorization and questioned everything, frustrating his teachers. One even told him he'd never amount to anything. But Einstein thrived outside the classroom, devouring books on physics and philosophy. At Zurich Polytechnic, he often skipped lectures, preferring to study great physicists on his own. He relied on a friend's notes to pass exams, not out of laziness, but to focus on what truly mattered. His independent thinking made him an outsider, but it was this refusal to accept dogma that prepared him for greatness. Einstein wasn't just learning physics, he was probing its foundations, searching for cracks in our understanding. This relentless questioning would soon change the world. After graduation, Einstein worked as a clerk in the Swiss patent office. The job was simple, leaving his mind free to wander. Here, he conducted thought experiments, Gedanken Experimenten, that would reshape physics. At 16, he'd wondered, what if you could ride alongside a beam of light? According to physics then, the light should appear frozen. But that didn't make sense. This paradox gnawed at him for years. Was something wrong with the laws of electromagnetism, or with our ideas about speed and motion? Most would have given up, but Einstein trusted his imagination. He spent years wrestling with these questions, using thought experiments to test the limits of what was known. He realized that to understand the universe, he had to let go of common sense and follow the logic of his imagination. This journey would lead to a revolution in our understanding of space and time. In 1905, a young Albert Einstein, then working as a patent clerk in Switzerland, published 4 groundbreaking papers, what would later be called his miracle year. These papers would forever change the way we see the universe. One of these papers introduced special relativity, a theory built on 2 radical ideas. First, that the laws of physics are the same for everyone moving at constant speed. And second, that the speed of light is always constant, no matter how fast you're moving. This was a direct challenge to centuries of common sense and intuition. The world as people knew it was suddenly upended. Imagine you're in a fast-moving spaceship and you turn on a flashlight. Incredibly, the light still moves away from you at the same speed, no matter how quickly you're traveling. For this to be possible, something even stranger must be true. Space and time themselves must be flexible. able to stretch and compress depending on how you move. Time slows down for fast-moving objects, a phenomenon called time dilation. The faster you go, the slower your clock ticks compared to someone standing still. At the same time, space contracts in the direction of motion. Objects become shorter as they move faster, a concept that defies everyday experience. Space and time, once thought to be separate and absolute, are actually woven together into a single fabric, space-time. This fabric bends and flexes, shaping the universe itself. This was nothing short of a revolution. Time isn't universal, but depends on your motion. Two people moving differently will actually experience time differently. And this isn't just abstract theory. Today, GPS satellites must account for relativity, or their data would be wildly inaccurate. Without Einstein's insights, modern navigation would be impossible. Einstein showed us that our everyday experience is just one perspective among many. The universe is far more complex and mysterious than it appears on the surface. The universe is far stranger than we ever imagined, filled with wonders and paradoxes that challenge our understanding at every turn. Special relativity didn't just change physics, it changed our understanding of reality itself, opening the door to new discoveries and new ways of thinking. It's the foundation for much of modern technology, from particle accelerators to the electronics we use every day. The world we live in is built on these revolutionary ideas. Einstein's ideas made the impossible possible, inspiring generations of scientists and inventors to push the boundaries of what we know. The world would never be the same, and our journey to understand the universe had only just begun. Later in 1905, Einstein published a short paper with a world-changing idea, E equals sign mc2. Energy and mass are two forms of the same thing. You can convert one into the other. Even a tiny amount of mass contains an enormous amount of energy. For decades, this was just a beautiful theory. But in the 1930s, scientists split the atom and found that missing mass turned into energy, just as Einstein predicted. This unlocked the power of the stars here on Earth. E equals sign mc2 went from a theoretical whisper to a force that would define a new age. The equation explained how the sun shines, and how humanity could harness atomic power. Einstein's simple formula changed the fate of the world. The universe's secrets were now within reach. Special relativity was brilliant, but incomplete. It didn't explain gravity. It described how space and time are woven together, and how the speed of light is the ultimate speed limit, but it left a crucial question unanswered. What is gravity, really? Why do objects fall, and what keeps the planets in their orbits? For 10 long years, Einstein searched for a deeper answer, wrestling with equations and ideas that would challenge the very foundations of physics. He was determined to go beyond what anyone had imagined. Newton saw gravity as a mysterious force pulling objects together across empty space, a force that acted instantly, no matter the distance. But Einstein wasn't satisfied with this invisible action at a distance. He imagined a man falling from a roof. During the fall, gravity seems to disappear. The man would feel weightless, as if floating, even though he's accelerating toward the ground. This led to his happiest thought. Gravity and acceleration are indistinguishable. If you're in a sealed room, you can't tell if the force you feel is from gravity or from the room accelerating. The key was the principle of equivalence, a revolutionary idea that would become the cornerstone of his new theory. Einstein realized gravity isn't a force at all, but the warping of space-time by mass. Massive objects like stars and planets bend the very fabric of the universe around them. Picture space-time as a rubber sheet. A heavy ball curves it, and smaller objects follow the curves. This simple image captures a profound truth about how the universe works. Planets orbit not because of a mysterious pull, but because they follow the curved paths in space-time, moving along the contours shaped by the sun's mass. This is general relativity. Gravity is geometry, a radical new way to see the cosmos. The theory predicted that gravity could bend light, a bold claim confirmed during a 1919 eclipse when starlight curved around the sun just as Einstein had calculated. General relativity rewrote our understanding of the cosmos, revealing the secrets of black holes, the bending of light, and the expanding universe itself. Einstein had revealed gravity's secret dance, a cosmic choreography that shapes the universe and forever changed the way we see reality. As World War II loomed, Einstein, a pacifist, faced a terrible dilemma. German scientists had split the atom, unlocking E equals sign mc2's power. Fearing Nazi atomic weapons, physicists urged Einstein to warn the US government. In 1939, he signed a letter to President Roosevelt, urging research into nuclear weapons. This letter sparked the Manhattan Project. Einstein didn't work on the bomb, but his warning set events in motion. When atomic bombs ended the war, Einstein was horrified. He called signing the letter his one great mistake. For the rest of his life, he campaigned for peace and nuclear disarmament. The atomic age had begun, forever shaped by Einstein's science and his conscience. His legacy was now tied to both creation and destruction. Einstein didn't just change physics, he changed our view of reality. Before him, the universe was a clockwork machine. After him, it was dynamic and strange. General relativity became the foundation of modern cosmology. It explained the Big Bang, the expanding universe, and predicted black holes. Einstein's equations even predicted gravitational waves, ripples in space-time from massive collisions. For decades, these waves were undetectable. In 2015, scientists finally heard them, confirming Einstein's vision a century later. His legacy is not just in discoveries, but in his method, imagination, questioning, and relentless curiosity. Einstein taught us to challenge accepted truths and explore the unknown. His theories are a gift to all humanity, a new story about our place in the cosmos. Einstein's story is about the power of curiosity. It began with a compass and led to a new understanding of space, time, and gravity. He showed that the greatest laboratory is the mind. His ideas shape our world, from GPS to nuclear energy. But his most important lesson is to never stop asking questions. Look at the world with wonder, as Einstein did. The universe is full of mysteries waiting to be solved. The next breakthrough could come from anyone, maybe even you. Nurture your curiosity. Let it guide you. Don't be afraid to question everything. Explore, share what you learn, and keep the journey going. The story of discovery continues with each of us. Keep looking up.